Have you ever wondered how your microcontroller knows whether to turn on an LED or read the press of a button? It is all about how you communicate your instructions to its physical pins. These crucial instructions are given through configuring specific areas of the microcontroller's memory, known as General Purpose Input-Output, or GPIO, registers. The essential steps for configuring GPIO registers involve first identifying the specific pin you wish to control, then setting its operational mode, and finally, managing its electrical state. This process establishes the fundamental communication link between your software and the external hardware connected to your microcontroller. The reason these steps are so vital lies in the very nature of embedded systems. Microcontrollers cannot inherently distinguish between an input or an output device connected to their pins. They rely entirely on your software to define the pin's function. By writing specific bit patterns into these dedicated GPIO registers, you tell the microcontroller, for example, that pin 5 should act as an output to light up an LED, or that pin 10 should be an input to detect a button press. This direct hardware manipulation provides precise control and prevents unintended electrical conflicts. To put this into practice, the first step is to set the pin's direction. You accomplish this by manipulating the data direction register, often abbreviated as DDR, to make a pin an output. You would typically write a 1 to its corresponding bit in the DDR to configure it as an input. You would write a 0. Next, for inputs, you might need to enable an internal pull-up or pull-down resistor to ensure a defined state when no external signal is present. For outputs, you would then write a high or low value to the port output register to set the pin's voltage level, either turning a device on or off. For inputs, you would read from the pin input register to detect the current state of the external signal. Understanding the distinct roles of the data direction register, the port output register, and the pin input register is an insider detail that truly empowers you in embedded programming. For instance, some microcontrollers offer advanced features within these registers, such as configurable drive strength or slew rate control, allowing for even finer tuning of electrical characteristics beyond simple input or output. Knowing these specific register names and their bit-level operations is key to truly mastering your microcontroller's hardware interaction. By systematically identifying your pin, configuring its fundamental direction, and precisely controlling its electrical behavior through GPIO registers, you gain the power to seamlessly bridge the gap between your code and the physical world. This methodical approach ensures reliable operation and unlocks the full potential of your embedded system designs, enabling your microcontroller to interact predictably and effectively with its environment.